Welcome to the Delta 5 Race Timer series. This is part 1. We're going to go over a little bit of overview of the system compared to others, then the parts, and then we'll go over the hardware assembly. Alright, welcome back to the channel. Recently I've been getting into racing, and I purchased a few timers. The TBS personal timer and the lap RF puck timers, I usually call it, but it's the personal timer here. Both of these work really good by yourself. They all have the ability to track multiple pilots, but the problem is they've only have one receiver module in these things. So when you start tracking multiple pilots, that receiver has to switch between two video channels to try to track your time. You know what happens? You start losing laps and basically you just start having issues with them all around. They work really well by yourself, and they work really well for tiny whoops, just because they're slow enough that that receiver module has a chance to switch and catch lap times. So flying full-size 5-inch quads that are a lot faster with more than one person, these things are just an absolute nightmare. You might be able to get 2 people with this one. This one, I wouldn't even bother. This is great for tiny whoops or by yourself for the most part. But with trying to fly with more than one person, they're just unreliable, and they're more headache than they're worth. Not saying they're bad products. They're just not for the group setting. That's why both companies make, like 8-way timers with 8 receiver modules. So what do we do now? Do we buy the Immersion RC 8-way timer or the big TBS timer, they're all very expensive? Or put these aside, we build one of these guys, the Delta 5 timer. Awesome thing about this is it's one node, one receiver per pilot. So there's no switching, there's no issues with that. It has the ability to be integrated with live time, and it can be done for a fraction of the price of any of those other timers. And it's a nice little DIY project. It's all open source, and I've flown with these. They work great. I mean, it's amazing how well they work. And they're fairly customizable too. So today, I'm going to build up one of these. All right, here we go. All right, for this timer, here are the things we're going to need. We're going to need 3D printed case. This one, it's short. This is for the 4-node timer instead of the 8. Need one of them, and a cover, and a bracket to hold the PCB. The Delta 5 Race Timer PCB. A Raspberry Pi 3. 4 Arduino Nanos. 4 RX 5808 modules, a 3.3 volt Pololu regulator, a 5 volt regulator, an XT60 connector, some heavier gauge power wire. This is 14 gauge. A couple of these little servo jumper wires, 4 100 kilo ohm resistors, 12 1K resistors, 4 of these little jumpers, and a ton of pin headers and sockets. I'll leave a list of parts in the description, and some M3 screws. Okay, so the first thing we need to address are the Arduino Nanos, the RX 5808 modules, the regulators, and this PCB here. The PCB is not necessary, but it's all laid out for you. It's very easy to follow. I do recommend this. The Arduino Nanos, just buy the cheapest ones you can find. Buy an extra just in case, because quality is kind of, you know how it goes. The Pololu regulators, I would suggest using these exact ones because that's what this board was made for. So the 2850 is the 5 volt step down regulator, and the 2849 is the 3.3 volt step down regulator. And 5808 modules, RX 5808 modules with the SPI mod done. If you don't know what that means, just just search for them, you'll find it. It's usually listed as SPI, whatever. And the other thing is this timer can be set up for anywhere from 1 node to 8. So if you only wanted 1, you don't have to buy all this. You just do 1 Arduino Nano, 1 RX 5808. You still need the 2 regulators. Whether you're doing 1 node or 8 nodes, it's still just these 2 regulators. If you want to do 8 nodes and you like the PCB, you just got to get 2 PCBs, 8 of these and 8 of these, or any combination between 1 and 8, just depending on how many nodes you want to set up. And the difference is for the 3D print, the case, the 8 node case is just a bit taller to accommodate 2 of these boards. All right. And the other thing is all the pin headers and sockets. Not necessary, but highly recommended. You know, these are electronic components. They're going to be out in the heat and elements. They can fail. It'd be a lot nicer to be able to just pull out a part, throw it away, put another one in, rather than having to desolder everything. So you're going to need the pin sockets and the pins themselves. Just a tip, when you do go to cut these, let's say you need 10 pins, cut past the 11th one, because they typically split. If you can see her focus, they typically split, and then you got to kind of pick the pin out, and then you can trim them to length. So always trim these 1 more than what it is you need. And then as far as the pins themselves, they're perforated, or at least these ones are. Just go ahead and cut them with a set of diagonal cutters, nice sharp precision ones. All right, so the first thing we need to do is we need to prep all our Arduino Nanos. These are El Cheapos. They are this brand. I'll put links to everything in the description here. They were really cheap. I think I got, I don't even know how much I paid for them. It wasn't much. But they did come with pins. They don't come pre-soldered, so you got to trim them to length. And we'll go ahead and solder them. It's pretty easy to do. Yourself a nice hot, clean soldering iron, and just go ahead and make sure I'm centered up here. And just go ahead and solder 1 pin here. There we go. Now what you can do is flip it over, and you see how it's not straight at all. Just kind of stick your fingers on there and press down to straighten it out while heating that pin back up. And once you get straight, go ahead and take your heat off, and boom, everything should be right in line. And then, you know, avoid touching that pin. You just kind of go down the line. If you find the solder's not flowing all that well, these dirty, cheap Chinese electronics, you can just hit it with a little bit of flux. That should make your life a little easier. There you go. That's 1/2 of one board. Yeah, I probably could have done a little better job on some of these, but I should probably go through and change the tip out on my iron. It's a pretty big one. There we go. So that is 1/2 of 1 Nano. You notice the pins are nice at a 90-degree angle here, nice and straight. So now we just got to do it for the other side. Process is exactly the same. Just rinse and repeat. And there you go. That's 1 whole Nano done. Now just do it for the rest that you have. And we'll be back once we're done. 4 little knockoff Nano soldered up. Okay. Next we're going to move on to this PCB here. If you're interested in one, I'll put links to where you can get these PCBs. in the description below. Everything's marked out really well. All the Arduinos go in these spots here. So let's go ahead and solder the sockets to the board. Same sort of process. Kind of stick a row of sockets in there. And go ahead and just kind of solder one pin in. Let it cool, flip it over and check to make sure it's straight, kind of at a 90-degree angle. If it's not, apply a little bit of pressure. Go ahead and heat that joint up and let it re-solidify. And then do the same for the other end. And make sure it's pushed flat against the board there and at 90 degree. And that's that. And we'll go ahead and solder up as many socket rows as you need for your setup. All right, now that I kind of got everything kind of tacked in place, go through and kind of hit up all the little pads. I'm using a no clean flux paste, but I'm still going to clean this stuff off. And just if you're curious, I'm running my iron at about 850 degrees Fahrenheit. If you've seen any other of my videos where I'm soldering, I know that a lot of people say that's too high because the melting point of solder is way lower, but the lower your temp, the longer your dwell time. If you can get in, get on the pad, and get out fast enough, in my opinion, this is the better way to do it. And I'm just looking over my solder job, making sure there's nothing that's under soldered, make sure there's no bridges, obviously. It'd be pretty difficult to bridge these, they're pretty wide gaps. And then just go ahead and see if our nanos fit. This will make future repairs or upgrades or whatever it is that you run across. It should make this pretty darn easy. Just making it nice and modular like it is. It's a very, very well thought out design. Cool. All right. Alright, so since we're working on the PCB, let's go ahead and finish soldering up all our other little pin headers we got. Up here is where your RX5808 modules mount. You could direct solder these if you would like, or we could go with the whole modular theme and put some sockets there, and then we'll eventually solder pins to the 5808 modules so that we can have these to be modular as well. So let's go ahead and slaughter these guys up. There we go. That's that. Now, on the side of the boards here, we've got ground, the SCL and SDA, where it talks to the Raspberry Pi, and then 5 volts. So 3.3, that's the comms, and then your 5 volt. So we're gonna go ahead and solder just some of these 2-pin guys here. Again, you just kind of custom cut these as you go. These are gonna be a little more fiddly, just because you're not you don't have a whole lot to kind of anchor it, so might get a little warm. But that's that. And these don't need to be perfectly straight. Your little jumper wires connect to those. And if you're doing a 1-board stack, you honestly only need to do 3 of these, either on this side or this side. The idea is, if you're doing a 6 to 8 node setup, you would just jumper from this board to the next board, making it nice and modular. Again, extremely well thought out design. All right, so that's this side. I am going to do this side, even though I'm not planning on doing a more than 4 node setup. Just to kind of future-proof it in case I do want to go with more. All I have to do is basically do another one of these boards and print out a different case. We'll go ahead and solder these up anyways. All right, that's that. All right, next is these 2 little pin headers here. And the idea for these is you use your little jumper, you connect those, and it'll power on that node. So if you were flying out by yourself, you could theoretically disconnect the nodes that you don't want to use, just to save on power. But talking to the developer of this board, it sounds like there was a small issue when the board was designed out, and they're all connected anyways. So I don't think it actually does anything, but we're gonna put them in there anyways. I have a feeling we could probably cut some traces and make this work, but okay, a few more things. All right, we'll solder up our pin headers for our regulators. Same as all the rest. Those are our 2 pin headers. All right, next it's time for some resistors. So I'm gonna go ahead and do the 100K resistors first. Just go ahead and pop those off. Put a little bend in the legs like that. You know, this doesn't have to be nothing crazy. It doesn't matter the direction you put these in here. It just matters they go in the right spot. So just pull them down flush, and then just kind of fold the legs up and out of the way like that. Or you can even go, probably this way's probably better. Just kind of fold them up out of the way, like so. And just like everything else, hit it with some solder. There we go. And then go ahead and give it the old snippy snip. Oh, this board is so sticky from the flux. No worry, we'll clean this all off when we're done. And that's that. That's one resistor. Go through and do the rest. There we go. There's all our 1K resistors, 100K resistors. I'll go through and do the remainder of the 1Ks. Alright, that is all the resistors, all the pin headers, or sockets, whatever we're going to call them. Only thing left is our power connections. And for this, just do normal XT60 type work here. Nothing too crazy or special. All right, there's our power wire. Okay, set that aside. All right, RX 5808 modules. It's going to be a little more difficult to solder because there's not really pinholes. There's just kind of like these half crescent cutouts. Just like pretty much everything else we've been doing, just get a little bit of solder on there and get it in place. And then we can rearrange it from there. All right, so now that we got our board cleaned up and we got all our bits and pieces cleaned up, the next thing we need to do is we need to verify that our voltage regulators are working right, because I can't tell these two apart, the 3.3 and the 5 volt ones. There's almost nothing distinguishing between the two. So what we're going to do is we're going to plug our 5 volt regulator in here. And just to note, there's only 4 pins needed, but there's 5 on the board. So that top one's just going to hang out there in the open. And we're going to go ahead and plug in that 3.3 regulator here. And we're going to power it up. I just got 4-cell LiPo here. We'll power it up, and we're going to take our multimeter. And if you don't have a multimeter, get one. These things are dirt cheap now, and they're actually really good. I really like this one. It's it's very accurate, very reliable, very affordable. I mean, it's no fluke, but I mean, for what we're doing here, we're not out in the field in an industrial setting. This thing works great. I'll put a link to this in the description below. So what we want to do is verify that we've got our voltage regulators in the right spot. So these two pins here should be 3.3 volts. So let's go ahead and check. And yep, 3.3 volts. And this one here should be 5. Yep, okay, so I got my regulators in the right spot. Ignore the fact that that was a -5. I just have the all right, here, I'll show you. If you're not familiar with using a meter, if you hook your leads up backwards, it just shows you a negative voltage for DC. So not a big deal there. So we know we have our regulators in the right spot. So I would take these out and mark them somehow. So as you can see, what I did here is I marked 3 volts and 5, marked 3s and 5s on these just in case they ever come out and get mixed up again. So I don't think putting 3 volts on the 5 volt pads will be all that bad, but I think putting 5 volts on that 3 volt pad would probably not be too good. So there we go. We got our regulators straightened out. We can leave those out for now. Just want to test fit everything, make sure everything fits in the PCB properly, and we'll go over to the computer and we will flash our Arduinos, and I'll show you how to do that next.